Well, welcome everyone back to the podcast. We're about, I don't know, I'd call it mid-season, Henry, wouldn't you? We're about
Yeah,
mid-season
about
right now.
mid-season. Yep, we have some potential guests coming up that are exciting, and one that's here with us right now that's very exciting.
Exactly. Yes, we got some traveling coming up and just came off the road where I got to meet this person in person, and that's Cees Veth. Veth. Welcome, Case, to the podcast. How are you today?
Likewise, I'm fine. As I said, it's 4:15 in Amsterdam. So work-wise, we're done, but I'm doing okay so far.
Yeah,
How
you
about
you
you guys?
traveled quite the distance out to now remind me, you went to Grand Rapids, Michigan. Is that correct?
Yeah, I took a flight from Dublin to Boston, Boston to Detroit, Detroit, Boston, Boston, uh, Dublin, Dublin, Amsterdam. The reason I went by Ireland, though, is the fact that it took me 90 seconds to cross the U.S. Customs instead of getting into, Pennsylvania, New York, Philadelphia,
Uh,
Boston, and wind up with about 2 hours. You know, it's a real pain in the, what do you call it? The traceable, what do you call it? So I
travel.
prefer the 60 to 90 seconds on Dublin Airport. It's just amazing. So that's a good deal that Aer Lingus made. But that's a kind of commercial. Let's move on.
Oh, it's
Well,
good. They're
no,
foreign
yeah.
travelers and people that are traveling. It's the same thing for with us when we go into other countries. Sometimes you're in customs forever, and sometimes it's a breeze.
That's right.
Yep. And
So
then
yeah,
so that was the Grand
go on.
Rapids chapter, correct? Like that's where you were at, right? Grand Rapids, Michigan, and then you came over to
Right,
Boston where I was at.
Didn't you
right. We
attend
were
the
first in
A2LA?
Troy. Sorry?
Weren't you at the A2LA Tech Forum as well?
No,
No.
Oh,
just I went to Troy, Michigan, together with Mike Taylor. He is from Monroe,
Good.
mhm.
south of Detroit. Troy is north of Detroit. And that was on Wednesday 8. And in the afternoon, I took a flight back to Boston and picked up Baton. And Thursday morning, in collaboration with three other persons, like Ryan, for example, uh, we did the same thing at ESCO Calibration Laboratories down
Oh,
in Chelmsford, Massachusetts.
Right,
that's
yeah.
where I saw it. I was gonna look the post up because I saw you down there. So you were at ESCO.
You were fooled probably
Right.
by Heather Wade being there as well.
Yes, that's why
Yeah,
I
yeah,
was
Heather,
because Heather was
and
there and Heather posted it. Yep. Mhm.
right, and the American speaking Dutch, like
Oh yeah,
Thomas.
Thomas Harper. Yeah, Thomas Harper, who is the American that can speak Dutch. Yeah, we it
Right.
was quite the
So
NCSLI chapter meetings getting international. It's very impressive. We have
right,
that Grand Rapids, bringing in Case, and then the Boston one had Case as well as Thomas Harper. So impressive
right.
stuff.
Well, that's
And the
fantastic.
guy from Seattle came in too in Troy.
Right, I think. Oh yeah, that's Sandeep
South is correct. That is
from
indeed
MetCore.
correct. Correct. Correct.
Yep, from that
Yeah.
way.
What, who is supposed to be? He's going to come on the podcast this season, I believe. So looking forward to that one as well. But
Right.
focusing on you, uh, with like your career totality Case, do you mind just starting off with that? How did you get into metrology and calibration to start with?
Well, as I said in my autobiography, I was always, interested in the facts about the how things occur, how things being measured, and we have the I don't know what you call it. What do you call it in English? Quasimodo. If I mention that word, Quasimodo,
Yes.
um, we have that kind of joke about the metrology and the Quasimodo kind of character in the island of Zanzibar, uh, having problems with a boat and being screwed up on the beach. And every time when the bell rings on the city down south, they have to show up and to organize whatever. And the main line of the story is that when he hit the bell at 12 noon, by the time they hear the sound and by the time they find the boat and by the time they got over there, it was 2 days later. So it's a kind of, it's amazing for me that that still in Europe, people looking at me saying, "What do you mean with 5/4? 5/4? 1 1/4? No, 5/4." And on MPT, UNC, UNF, left-handed, right-handed, tubing, excise, OD, ID, and all this jazz, and all those enormous amount of manufacturers of fittings and all that. Like Swayslock is very familiar in the US and in Europe as well, but there is more between Swayslock going to 6,000 psi and all the rest of the manufacturers. So talking about that, talking about the never-ending story on birthday parties or anniversaries about gravity, mass, weight, and all this jazz. And they're looking at you and they're saying, "Oh yeah, now we understand." And 5 minutes later, "Did you really?" "No, I don't. I don't understand." And it's so simple if you take time and try to realize between your ears what people are telling you and add things up, and then you find out scoops of it. Anyway, that's fine that you have this design, this school, something, in the States as well, and I think every country in the globe, they don't have any educational level on calibration or metrology. So when I hear it from Mike Taylor, when he explained me that he was teaching metrology on a university level in Monroe, Michigan, I was really interested in order to receive some. How does that look like? What is the content? What is the level of pre-education in order to follow that up? And then I actually, in Holland, it used to be like our calibration, it's costing money. As long as I have an instrument with a sticker on it says it was done yesterday, I'm fine. And that's why I had my negative reply on 9001, because calibration and 9001 had nothing to do with one another in my personal thoughts. So 17025, however, is an entirely different issue, and I have problems to getting my system, my deadweight tester assembly, to get that organized with the 17025. And lots of people say, "Well, why don't you do it with 9001? Where should I? What is the value of that?"
Right.
It's costing me time. It's costing me money. It doesn't bring me anywhere. So it's not. There is no additional effort in doing that. But anyway,
so Cees, for those that are listening here, and we didn't cover it yet, Cees is what we consider does high pressure, very high pressure.
Yeah. Many people listening will think that their lab does high pressure until they find out how high a pressure Cees does.
So with that story where you were going, I interrupted you a little bit so people could know where we're going with this, because Cees got into pressure, and the 9001 to 17025. I had the privilege we were looking at one point, Cees, we were thinking about buying the machine that you have, and it just didn't make sense at that point in time. Our engineering team, we have one of our engineers made pressure transducers for 15 years, and we had Air Force contracts and nowhere to put it. And then we got into this 17025 and the accreditation part where Cees is going, that yeah, it's one of the things, closing all those loopholes and figuring out the measurement uncertainty of the system. But with that, yeah, please continue.
Well, all I'm saying is the Dutch accreditation body, R3A, that's what the abbreviation sounds like. They told me that we are not familiar with that range of pressure. We're familiar with 5,000 bar, and that's about it. Okay, everybody their own knowledge and know-how. There's no problem. Meaning say that is that the one who is able to do so is, for example, the German National Metrology Institution in Braunschweig.
PTB.
And yeah, PTB, right. And I've been there many times, many times. I know many people in the relation of pressure and force, that is. And so I discussed it with them, but they are not allowed to run any 17025 in relation to my equipment because the European Union law forbid me as a Dutch, what do you call it, established company to do business in another member state in the EU. I am also not allowed to do that in the States or in anywhere else in the world. I'm a Dutch company, I'm Dutch registered, so I have to go to the RVA. And the RVA is going to invite people from the PTB. That's how things work. But the PTB is, and that's the second issue that I mentioned in my autobiography, is the fact that I don't understand why an enemy is operating on a commercial market to start with. With all respect of, and we do need NMIs, the same like NIST, we do need them, and they have to be there, of course, no discussion about it. But I don't understand why they, operate on the commercial market.
Well, Cees, there's probably a lot of people listening, at least over here, that don't even know that there's NMIs in the world that are commercially run, like privately run labs.
Oh, yep.
Where here in this,
That's how we got the torque machine.
Yeah, it's crazy. Like,
right, that's how we got the torque machine from NPL. It wasn't.
Just, you could take it.
Yep. Yeah, they wasn't making money. It was my understanding. It wasn't making money for them. It's privatized, very commercial, and since it's not making money, that they're selling it in space for something else. So we ended up purchasing the second most accurate torque machine in the world, and now I think Cees has probably one of the most accurate high pressure machines in the world.
Well, the measurement uncertainty, the CMC of my equipment is estimated by a very highly respected gentleman within the PTB and within the high pressure business. I'm not talking about only NMI in Braunschweig and Berlin in Germany, but also Imeco. You're familiar with Imeco too, I assume, Ryan? And Euromet, the Association for Accreditation Bodies in Europe.
Yep.
And the measurement uncertainty of the equipment that I have is way over specified by this gentleman. And if you look to high pressure equipment above 1000 megapascal, they all look the same principles. Hanging instead of standing, a dual pressure sequence on the piston cylinder assembly instead of signal. And yeah, as far as I know, there were 6 machines of these on the globe. And the last machine is parked down in Marietta, Georgia. And there is one on the NMI in New Delhi in India till 10,000 megapascal, and there is one a kind of one parked in the PTB in Braunschweig, and there is one parked in the university. Used to be one parked in the University of Liverpool, the UK, and there used to be one on proving ground in Aberdeen, in Maryland.
That's the one you purchased. No, that's not the one you purchased.
No, the one that I have is originally made by Donald Duhall and shipped to the University of Amsterdam.
Okay. And
nobody knew about it because they were using it scientifically and not commercialized.
Oh,
right.
Okay.
They had students going through that program, if I remember some of our discussions that we had over time, Cees. And for those listening, Cees is saying megapascal, but your machine goes to what?
My machine is originally made in the first level of negotiations between the university and Van der Waals laboratory and Donald Newhall was made for 14,000 kilograms centimeter square. 14 kilowatt, 1400 megapascal, right? Whatever.
Right.
And during the manufacturing, the professor at the university said, it's not enough, I need 1,000 more.
Yes.
And the university and the hardware company in Walpole, Massachusetts together redesigned the basic, actually the main high pressure enclosure that is on top of the entire system. And they redesigned that together with a piston cylinder assembly, and they wind up to 50,000 kilogram square centimeter, or centimeter square, what's the correct pronouncement in English? Centimeter square, I guess. And that's what I've used for years. And all of a sudden, from a German company and a Norwegian company, that's all I can say about it, though. They say, what about 60,000 bar? I said, okay, how many you got? What is the process connection? What is the output signal? That's what I want to know. How big is this baby, you know? I mean,
Yeah.
Do I need a 7-Eleven boy, or do I need a big transportation company to get things established? But actually, it was a big bomb, like the old Mega Tide model, to 200,000 psi with span zero. And he sent that thing with an M20 by 1.5 male connection, like Hottinger has and Vika. And all I said, well, let me look into it. So I called, not Donald Newell, he passed away in 7. So I called his son and I said, listen, this is a question and I have this in mind. And William said, you make your engineering, you come back to me and I'll look over it and I'll come back to you, which happened. And about 3 months later, he said, if you do that, that will cover the percentage of sanity that we designed and engineered in the main high pressure enclosure. So then I redesigned the piston cylinder in size and also in material. That was a little pain in the, what do you call it, to get that thing made. We finally established that in Austria and in Luxembourg. In Austria, they made the cylinder, and in Luxembourg, they make the piston. And the two babies, they fit like, you know, whatever you call it, a decent Friday afternoon English, but they fit pretty good. And the other problem was the calibration to calculate the piston effective area. And then again, I went into the second pyramid in order to find, the world is getting smaller and smaller at that time.
Right.
So finally, I got in touch with a gentleman in Farmington, Connecticut, Edmund Gages. And Chris Mikey is running the show there, and he did a hell of a job together with John and his colleague. And they calibrate those two issues. And that's the one I brought with me, Ryan, in Tedesco. Remember that I had on the tables the piston cylinder.
Unfortunately, I had to take Thomas to the airport, so I missed that part.
Oh, all right. But anyway, I
Either way.
Yeah. I got it downstairs, but nevertheless, the original piston cylinder is made out of a kind of stainless steel. And the one that I made was one step back. The dual pressures on the high pressure enclosure is, in the worst situation to full scale, it is close to 200,000 psi on the jacket pressure, equal on the reference pressure side. And those comparisons between one another is pretty accurate. And that's what you're doing with the needle valves and all the other transducers on the deadweight system in total. So when I designed another material, it was difficult to get it manufactured, but it was even more difficult to get it measured. Anyway, they did a job in Farmington. I visited them last year, June, when I was in Connecticut. And I called a guy in Norway, and I called a gentleman down in Germany, and I installed the thing. I did the other procedures, cleaning and whatever, and then I really gently increased the pressure all the way up per 1,000, 10,000, 12, 13, 14, 15, and then you finally go over the edge. And when I applied all my dead weights, I wind up to 1625 megapascal, and they calculated 5% over the 1600. So everything went beautiful.
Wow.
And the outcome of that in 1,000, what was it? I did it per 1,000 bar. So you want to have it in bar in the output signal. It was a strain gauge related issue, so I had a meaningful full output, Wheatstone bridge, and I had it installed on my Hottinger amplifier, and that baby was, I mean, from 0 to 100% pressure is from 0 to 1.0, what was it, 1.30, 1.0004 millivolt volt. It's amazing. It's amazing technology on the Wheatstone and on the strain gauges that is installed on the material of the pressure transducer. The other issue actually is that I'm not allowed to say the company who asked me to do so, but I am allowed to say that they are in a kind of business, and high pressure is for them a necessity.
Sure.
You understand what I'm saying?
Yeah.
The tubing we're using is for the high pressure side. That's no big deal. You can buy that all over the globe. In variety from 916 OD to 3/4 OD, and with an 8-inch ID or a 16-inch of an ID. And it's not a $20 per foot though. It's a bit expensive, but
Sure.
I mean, I never had a blowout. And if you make sure that the OD 7/8 3/4 inch thread is in good shape, no damage on the pitch, and when the cone is nice and sufficient made on the lathe, you won't have a problem.
I was going to
As
ask.
long as you line up
Yep.
in a linear line with a good torque, you need a good solid torque gauge in clockwise and counterclockwise. You won't have any problem whatsoever.
I was going to ask you, Case, if you've ever had situations, especially in developing this stuff, where it gets a little bit scary just because it's so much pressure.
Well, the scary thing is if the connection is not done properly, so not lined up and not elongated in piping and fitting and coupling, you see some smoke coming.
Yikes.
You can imagine that when those things are mechanical, not in line installed properly on an angle or whatever, like the cone, and you are, for example, have to go to 15,000 and you are at 12 or 13,000, then you see a little smoke coming. Meaning, you hear this guy? You hear this, huh?
Look at him.
Yeah.
This is my solo phone. Perfect. You will stop soon.
You're all good.
So you have to think, when you see that, you stop and you just take with your hand the needle valve and turn left, and you drop the pressure. Nothing happened. And the remarkable issue you see is that when you take that part and start sweating, leaking, you see you see a burning place on the cone.
Oh.
Where the liquid went through. So you see the amount of what do you call it? The amount of deterioration,
right?
What the liquid did on the steel. That's amazing.
Yeah.
So you get rid of that piece and you make a new one. You make a new cone. You make a new thread. I got different tubes of stock.
You remake everything at that point.
Yes. I don't have a lathe, but I have a very good relative of mine living about 20 miles from here. He's doing all my labor.
Okay.
And he's got a control room. He's got all reference for UNF, UNC metric, fine metric, you name it. He got hundreds of that. He got an own granite table to measure. So it's a pretty good, accurate job. Company, sorry for my English. But anyway, he's doing fine. And he knows what it means when a static pressure occurs on a material. You know, he's knowing more than switching on the lathe. Let me put it that way.
Yeah.
And that sounds stupid, but
No, it doesn't. I think it's awesome for the listeners out here to hear this, because a lot of times people are going to shop on price.
Mm-hmm.
Well, if you're shopping on price with somebody that may not get you exactly what you want, does not have the quality controls, and then you're going to a high pressure situation, that's not a win. There's no way that goes well.
I visited in 2009. I visited Harwood for so many times with a friend of mine from Connecticut, and he had a test to 20,000 bar. You ever been at Harwood?
I don't.
No, you okay. Harwood is placed near a parking lot on the secondary road in Walpole, and behind there was the bush and the jungle, we call it. And he had there a kind of bunker made out of, what do you call it, those big beams under the rail tracks. You know, those big beams they use.
Oh, yeah.
You know, the big wooden, whatever you call it.
The stakes,
the ties.
What do you call them?
I'm thinking the big wooden things. They're like what are they? Like 4x4, almost like a 4x4s that they were laying down.
Pretty big babies, though.
Oh, okay. Yeah.
Anyway, he had a little house made in the back with a big table to install the dead end to pressurize. This thing had to move. So at 20,000 and a little bit, he went into orbit on a vertical construction. And we never seen him again. So he's probably chasing the Apollo 11 or whatever. But he went to an orbit, and we never find it back. But the energy that is needed on that piece of steel is the opposite, including. When this thing comes back, he has the same energy when he hit Mother Earth. So this was amazing, because Bill said, okay, he went, boom. And he started looking at his watch, and after 2 minutes, he said, now it's safe enough to go outside.
Yikes.
You know, he needed to do this in order to find, but the tubing didn't move an inch. Well, an inch, not a hair. So I don't know if you know the history about Harwood, but I believe, Ryan, did you receive the article from the metrologist? Yeah, there is an article about my equipment. I believe it's the November issue. Well, hang on, I got him here on the screen.
Yeah, they publish quarterly, so it might be the October, or it would have been a January, maybe.
Yeah, this is NCSLI Worldwide News 2023 Workshop Symposium, July 8, 12. No, this is volume 16, number 1. Anyway.
So those that are NCSLI members, volume 16, number 1 of Metrologist.
Oh, okay. Right. Mike Taylor, right.
Yeah, anyone that's listening that's out there that has an NCSLI membership, you can go pull the old issues of NCSLI Metrologist.
Okay.
If you're not a member, you can go online, and they have fees for some of the articles. I think they're like $20 or whatnot. But with membership, you get it all for free.
Oh, I think I found it. So what did you want to reference in it? Did you want me to put the pictures up when I publish this?
The reason I mentioned this is that on page, what do you call it, is my on page number 12. Okay. Anyway, the requests by the U.S. departments were necessary in their opinion because when the United States Army went to Omaha Beach, a number of American soldiers died on the way on the Atlantic due to the quality of food. And not to the quality of food, but the preservation of the quality of the food. And the department, story was told by Donald, and he said the Department of Health designed and invented a kind of preservation for food if you pressurize the food before you put it in fridges or whatever cooling application. And the reason saying this is that he finally made this, and they compressed 1 pound of chicken meat, and they were amazed about the time that you can save this meat if you pressurize that with bottled water for X amount of time.
Oh,
wow.
And you guys are familiar with high pressure processing?
Somewhat. I mean, I've done calibrations in some packing companies.
Well, in the world, there are about 4 or 5 manufacturers throughout the globe making machinery that pressurize food, juicy drinks, pet food actually, that will kill the bacteriological systems in the food and that save taste and vitamins. All I'm saying is what Harwood was doing in a collaboration with the Department of War and Health was actually the basis for the solid rations that military use on battles, so they call it, going to the battlefield.
Wow, interesting.
MREs.
Yeah.
That Ryan loves.
I've had a lot of MREs over my days.
Right. Okay. Right now they're using 6,000 bar.
Okay.
So it's worth. I strongly recommend when we finish to drop to Google and to fill in high pressure processing, and you will have an evening full of a show. There are some companies that do animation movies about how this works and why it works and so on and so forth.
Sure.
The other issue for high pressure is the ammunition and weapon industry. That is, the ballistics is enormous.
Sure.
And of course, the diesel engines is an issue with high pressure, with the common rail system and so on and so forth. The radio crystal manufacturing throughout the years was an issue that is used by high pressure. The diamond infill industry in relation to the special Kennedy press that Harwood used to make to 30, 40, 50,000 PSI.
Yeah, to make artificial
30,
diamonds, right?
Yeah, that's a huge
30,
business.
40,
Yeah, for mining equipment.
So 15,000 to make an artificial diamond, is 15,000 bar.
No, it's higher. But Harwood also made Kennedy presses to extremely high pressure, but just generating, not calibrating.
Right.
But anyway, in William Newhall passed away on March 7, 2021 during an operation in a hospital near Walpole. And 1 year later, everything was solved. So there were 3 issues to be solved. One issue was a deadweight tester. One issue was an enormous amount of spare parts. And one issue is the positive step generator, dynamic generator. It goes to 150,000 PSI within what? Within 0.5 seconds.
Oof.
It's a very, very interesting industry too, for dynamic pressure, right?
Mm-hmm.
And they're all sold in the States. And I spoke to all the people there. I had good communication with Bill's wife and his son. And yeah, all I know is that some great people who worked there went back home. One guy went to Florida, the other guy stayed in Massachusetts. But it's already a company since what? Since 78 years, 1940. 1947, I believe, or 46, the company was established in Walp.
Okay.
And remarkable stories I have heard from I will tell you that. So
Yeah.
remarkable people, very, very open, social. And the other issue is, and that is also in the article, I was talking about Euromet, the European Association for Accreditation Bodies.
Mhm.
In 2011, they had a program for high pressure. And I actually didn't know. So somebody from Travel in Belgium told me that this thing was going on during the exhibition of metrology in Paris in 2011.
Yeah.
And I went over there and well, I had a discussion with an organization that was run by the National Metrology Institution from Germany, Switzerland, LNE, Paris, France, and Hottinger Baldwin, that's a company in Darmstadt, and Vika in Germany, and an engineering and a university company in Slovakia and in Germany. But I was just too late before all the print work. So to make a long story short, I was able to have some conversation with these guys. And they were saying that the European Union needs a 1.6 gigapascal international pressure standard because of the industry who needs high pressure. This is 12 years ago, though. 11, yeah, 12 years, 12, 13 years ago. So, but again, I didn't know that. I was too late, but they didn't know that I had this equipment. And so we got together and I went to Paris and I went to Braunschweig later on. Did some traveling to, it's not as big as the States, but you can still do some traveling here, believe me.
Sure.
So finally, we came to a solution that, I was planning to, and I still want to get an accreditation. But as I said in my presentation at ESCO in Massachusetts, and what you can see on this interview with Mike, I'm turned 70, well, I hope so, in October this year, and hope some traceable years to go after that. And but I spoke with a gentleman from the PTB, and I spoke with gentlemen from the VNSRE, that is the Russian NMI, but they're not such kind of communication lately. So, that's another problem that's occurred. In order to have a possibility to have a cross-flow calibration on my equipment, any location, wherever.
Right.
But in Europe, it's about 6-7 hours from here to Braunschweig. Moscow is a different story, different distance, and a different application now these days, of course. But that's another issue. And but that's, I believe, that's my best goal. On the other hand, I know my mass. My mass is calibrated against 17025.
Sure.
I know my piston my piston assembly is my piston assembly area is calibrated against 17025. I have my gravity, and folks, ambient temperature, ambient relative, ambient barometric. If it's 16 degrees centigrade or 29 degrees centigrade, that does not influence my outcome in this high pressure range.
Because the pressure.
I mean, if you're talking about if you're talking about a couple of hundreds or a couple of thousand psi, then you do have a problem in the ambient temperature, of course. But in my situation, not at all.
The pressure
traceable.
itself is somewhat dictating the temperature, right? Because it's so high of pressure, it's going to be extremely
In a
hot.
way, yes, in a way it does, but it's not that if you generate a pressure to 200,000 psi that you can make a hot dog on the tubing. It's not that hot though.
Oh, okay.
No.
I would think it
of
would.
course, there is.
That's surprising
Yeah,
to me. I would think it'd
that's
be super hot if you're getting it up into the hundreds of thousands of psi. But so that surprises me.
No,
there's a lot of energy.
no. First of
Yeah.
all, the medium that we use and most of the calibration labs on the globe is Sabicate oil. I use Sabicate oil, but I also use a second medium. I don't only use Sabicate oil. And those two together in a ratio of X, I use for my reference fluid, so they call it. Pressure reference fluid, so they call it. And it works fine.
What is that oil called? Because I know here a lot of us look for triple filtered oil, the triple filtered tester oil for a lot of deadweight testers. What was the type of oil you said?
Sabicate oil.
Oh, I'm not familiar with that kind.
Nope.
What?
Sabicate is I believe that 80 out of 100 deadweight testers on the globe is used with Sabicate oil. There is another English word for it, but you have to take a day off before you can say it and you can understand it. So that's why I use it, Sabicate oil. And,
Okay.
For the other high pressures over 20, 30,000 bar, and not for calibration but for pressurizing.
Okay.
We use glycol ethylene.
Okay.
And you can cooling liquid, and you can use that to 40,000 bar at no problem. It's cheap. By the other end, it's hygroscopic. And you have to take that into consideration for the water molecules. So that's another issue. So I do not use that in my deadweight test. My deadweight tester is a mixture in an X ratio of Sabicate oil and a second medium. And when an equipment comes in for calibration, I put the thread of the instrument that I received. I clean that with ultrasound. And then I use it in my application. And when I'm finished, I clean it again before I knock it off with a plastic cap, the process entrance, so to call it.
Now, Cees, I know I have students listening that ask me, are there good apparatus for cleaning gauges? Do you have one that you recommend, or how do you end up cleaning out a gauge when you get it in with some sort of unknown fluid?
You mean a pressure gauge, a manual pressure gauge? Well, the problem with most of the pressure gauges for cleaning is that the the element that comes from the thread all the way to the end, the Bourdon tube, so they call it, is a dead end piece. There are some manufacturers that provide on the end of the Bourdon piece, they provide a little screw to bleed. If you clean your gauge with ultrasound, all those little little creepy crawlies that comes off the material surface, that has to go somewhere. And if that comes into the Bourdon tube, which is a dead end, it will stay there. If you open that screw, excuse me, then the dirt will go through and you can wash it out with water. There are many steps in order to do so, but that's what I do. For high pressure, however, I used to receive a 10,000 bar gauge that is a baby about 16-inch diameter. It's about 35 pounds. It's a big baby. And the issue is if you, on the end of the Bourdon tube, and this is a spiralized Bourdon tube, like the Heisey gauges has.
Sure.
You have that bolt you can screw out, and you can clean it, and the dirt will come out of that hole. That's very important. But you buy just a very good, solid ultrasonic bath, and you use just what do you call it? Sterilized water with some added cleaning material, and it works fine.
Great.
It works amazing.
Oh, that's helpful.
Not explosion, but implosion process on the surface of your equipment. But if you take gauges to 10,000 bar, 1600 bar, well, I believe 99 or maybe 99.9% does not have that blowout bolt on the end of the bourdon tube. And then you have a problem.
Right. That's a lot of the cheap gauges here don't have any opening on them.
Right. No opening. Right. That's what I mean.
Well, that goes back to the question of you receive something and you're expected to calibrate it. So do you calibrate it in the condition that it was received with the assumption of that's how someone was using it? Or do you clean it first and calibrate it, which is not exactly how it was being used?
Being used for me for high pressure are two issues.
Yeah.
Yeah, right. Well, first of all, the thread connection. The process connection is the main important issue. I have a bunch of dies. Do you understand what I'm saying?
Yep.
Right. So I take the what do you call it? I take the transducer, transmitter, whatever the sense from Metrology is. In one hand, I take the dice, and I have to move the dice with two fingers without squeezing, easily all the way to the end of the depth of the thread.
Mm-hmm.
If that is sticking, I'm facing a problem. I'm facing a blowout. It's not
a major and huge safety issue. Yes.
It could be wine in orbit. So the other issue is the angle of the cone of the process connections. All of the pressure transducers, transmitters, sensors are provided with a cone. Whether that is an autoclave kind of thing, or a hip kind of thing, or in Switzerland we have Nova Suisse, and we have CTEC, and we have all kinds of manufacture, or Harwood. As long as the cone is clean, is equal, and not damaged, I take care of the rest. So I got a bunch of male and female connectors that fits a lot of transducers on one hand, and that fits my reference pressure side of my deadweight test on the other hand.
Mm-hmm.
And they are clean as a baby's ass, and I want them to stay that way. No damage allowed.
Yeah.
The other issue is the fact what I just said about cleaning, about the ultrasound for the process section. So my question always is, I have a whole list of questions before I receive a question for, can you send me a commercial proposal for the calibration to 15,000 bar? I said, well, I also want to know your medium. I want to know what is the make, what is the model. I mean, if you buy a Hottinger high pressure blue line transducer, you can put that thing in any position. It's bar G. And Hottinger is an absolute pressure, so you can put them also in any kind of position. If you understand what I'm saying.
Yep.
Mm-hmm. Mm-hmm.
The Omega 9, for example, has a span 0 on it. You believe that? 200,000 psi with a span 0 facility, and it works amazing. Really, I was freaking out when I had that baby done with a deviation you won't believe. So I have to make adjustments with, of course, permission of the owner of the instrument.
Sure.
And this was for a company in France, and I know this was amazing. So I didn't believe that I was possible on that range, but why not? So coming back to your question, Henry. As long as the thread is clean, as long as the cone is good, in my decision, I am the one who making, well, not the show, but I am the one who decide if it is clean and if it is, perfect to do so. uh, and it's able to clean. And then I look to the residue of cleaning. If the clean water before cleaning is clean after the cleaning, and there is no crap in there, that tells me something about what process they have and how they treat it. You know?
Yeah.
I also look to the outside, to the stickers, to the quality of the service of the equipment. Is it been thrown or a lot of stickers on it or bended or whatever? You look to the quality of the communication cable, if they supply any. You look to the qualification, the quality of the display. Is it broken? Is the front plate in one piece? Is it a neat situation that you received? And that's for me the decision to do or to do not do the calibration, to do or don't do the calibration. And so coming back to what they receive after they delivered it, the same thing, only it's calibrated. And believe me, all the high pressure transducers, transmitter, and sensors that I receive from all over the globe, the accuracy that I found is less as the accuracy that they claim by manufacturing. So the manufacturing claim 0.5, and I went back with 0.7. So they went ape shit. Excuse me. They didn't like it.
Of course not. So, no one wants the truth in manufacturing, right?
Well, that's not surprising. I mean, I thought, a little bit back. Yeah, so they're claiming 0.5 and you're saying, well, no, it's actually 0.7. And then people say, well, what? Manufacturers said it was 0.5. What are you doing that you can't get 0.5, Cees?
Yeah.
Well, the reason.
Yeah.
First they said you're not accredited. That's the problem. Really? Okay. Well, all right. If that is the problem, that is the problem. So what happened is that they shipped the same equipment to an NMI in the world that used to do 26,000 bar. Not anymore. And they came to another final result on the calibration, 0.7. So, you know, I mean, don't get me wrong, but with what I'm going to say now doesn't sound nice. But if you have your area, if you have your mass, if you have your gravity, okay, if you have your temperature, relative humidity, if you have your barometric information, and you know the right mass of each reference pressure, represent each reference pressure, you will have a most accurate kind of reference pressure on your instrument.
Right.
Because deadweight testers are and always will be the most accurate way for reference liquid static pressure calibration. There is no electronically that can win. So you mean there are secondary pressure standards. You know, what are they? There are a manual pump that comprises a liquid. You got a manifold with 1-2 process connection, one for a very high accurate secondary pressure standard, so they call it, and the other one for a gauge, pressure gauge. Oh, it's a good comparison. But I don't understand the pictures that people using gauges, manual pressure gauges, you don't calibrate those with a deadweight test.
Right.
I mean, that is, how do you pronounce that? How do you make a comparison?
You just don't have the resolution.
Well, the most inaccurate kind of pressure measurements is a simple pressure gauge, with all respect for a pressure gauge. Yeah. Because a gauge is a very first-class kind of instrument. But the Heise can make 0.1 full scale, and a deadweight tester is always reading. No matter what, the worst deadweight tester is always reading.
Right.
So that was my situation in the comparison. And
I noticed
it's the same like force.
I notice that
It's
a
the same
lot.
like Force to Henry, right?
Mhm.
I mean, I got Hottinger. Am I allowed to announce brands and names and makes?
Yeah,
Is
that's
that a
fine.
problem?
No, yeah,
Yeah.
yeah,
Or
yeah.
do
HB,
some
yeah, it's HBM equipment.
yeah,
Yeah, great
it's it's
stuff.
it's
Yeah,
it's great stuff. But dead weights are more accurate.
yep.
I notice
Has
that a
nothing to do
lot
with Hottinger.
where
That's just
manufacturers,
the principle of right.
Right.
when we talk about, you know, sales and marketing stuff that's out there, you can't help but notice there's a lot of manufacturers. I'm not going to call out anyone in particular, but where they're really pushing the limits of what a pressure transducer can do and do on a regular basis, you know, kind of furthering your point, because a lot of places, if you look at it honestly, a commercial calibration lab runs a lot off of time, right? And deadweight testers and doing dead weight on a lot of things it just takes more time. And that, you know, and automated deadweight machines
Yep.
like the ones from manufacturers out there are expensive, you know? And so what do they want to do? They want to get a pressure transducer that can cover as much of that range as possible. But as I'm going around teaching, you know, I have these companies that are third party commercial calibration labs that are sitting there saying, yeah, are you seeing troubles with these out there? Man, we can't get these things to stay as accurate as they claim. And it's
Mhm.
like, yeah, they're getting right at that edge of where they can't do what the manufacturers are
Right.
trying to stress them to do.
Right.
Right.
And they're making millions of these gauges, right?
Mm-hmm.
Pressure gauges, they make a lot, you know, in our world, they make a lot of load cells, probably maybe less torsion cells, a lot of torque wrenches, though on pressure sensors and gauge, I mean, their pressure sensors are everywhere. If you think about
Yeah, in
almost
your
in
car.
everything, they're everywhere. You're not going to avoid them. And any
Right.
sensor, I mean, in your house, your
Yeah, your
water,
blood pressure.
right?
Blood
Blood
pressure.
pressure,
Yeah.
water pressure is coming. If you're hooked up to water, if you're hooked up to gas, if you're hooked up, yeah, I mean, it's all relevant. And yeah, but they're just just everywhere you look, and everybody needs them, and they want to make them cheap. And then you get companies. I'm sure you see this case is you get companies that say they're this good. You go to test it, and like you said, it's not that good, and then they're shocked. And I'm
Yeah.
sure you have who's making really good stuff that you're just, oh, if I see this, this is going to be a lot easier than some companies that are making things. And I wanted to ask you personally, how many, just off the top of your head, rough numbers, how many gauges do you reject that are sent in for calibration?
Yeah.
Yeah, that there's no way something's wrong with the threads, or the material's damaged, or there's just no way that you can.
No. One issue I recall that was actually for a display that went black.
Okay.
No reply on the display, no unit, no figure, no nothing. You have to understand that most of the high pressure transducers, Henry, are installed on a process connection in the plant, in the lab, or whatever they use it, and it stays there.
Okay.
I always telling that if you have a facility that runs on a 24 or 40 hours a week, whatever, install them, leave them. If you torque down the gate, the pressure the pressure sensor to the main connector with a cone, always with a cone,
Mm.
and you tie it down, leave it. Because at the time you tie it down, you got a kind of marriage going on between the inner cone of the transducer and the outer cone of the color that is used.
I see.
You understand what I'm saying?
Yep.
Mm-hmm.
Yep.
You got a cone from the transmitter,
Yep.
and you have the cone that comes in the main housing, and you start a kind of, it's a line issue, and you start to get a kind of marriage between they one another. It's like stainless steel and MPT thread. If that fits, it fits. Don't screw around anymore.
Right,
don't over tight it, and do it on a good way. Otherwise, you really have a problem with MPT. And so the damage of the thread that could be done by taking it out, having it on the bench, falls down on the ground. Don't pay attention with vertical position of the system. So make sure that that little cone is about, I would say, less than a quarter inch high and less than a quarter inch wide with a 1/8 hole. That's all there is to it. And that has to be in a perfect elongation of the main coupling where the sensor is turned into. That has to be a perfect fit. Now, if you buy the cones from Hottinger, they have a spring that support that position. Come to think of it. If you look, for example, on the website from Hottinger, you go to the blue line and you go to the 2 series to 10, 5, 10, and 15,000 bar, there are 2 series. You can go to the accessories and you will find those cones. They sold by 2 in a bag, and they have a little spring, and that spring goes into the process of the sensor, and that makes happening that the sensor and the cone is one straight line, so you can put the connector on top of that. It's they think about it, clever. And 99% of the leakage is that problem.
Sure.
You know, when that cone is positioned on an angle, you won't get it straight.
Well, and whenever you talk about stuff like this, it always cracks me up, because I know there's a lot of technicians out there that are doing day-to-day pressure work, and they have all of their fittings that they take to go work on people's stuff in a bag, all clashing together and intermixed together in a bag and just rattling it around. So those of you listening out there, this is the world expert on pressure. Don't be messing around with those connections. I think that's one of the most overlooked or biggest issues I see out there in pressure is people misusing their connections and their adapters. So that's definitely important.
In the boxes and the material, huh? I mean, I am one of the old school, meaning that the material of the fitting is the same or better as the material of the tube. It's the first law you learn by Cees Veth. 3 issues. The fitting is the same as the tube, or the fitting is more quality-wise than the tube. Don't use a brass fitting in a stainless steel tube. That's what I'm saying. Exactly. The other way around is not advisable, but you can do it. The second is 1/4 inch to 6 mil is 3/4 finger tight. And from 1/4 inch up to, I believe, 3/4 is 5/4 turn from finger tight.
Okay.
And meaning that if you install that tubing and you deinstall it, you got the dual fairings on the tube. And as soon you can turn the dual fairings when they're installed, you're doing a good job. When you cannot allow that to turn, you can open your B bottle with it, if you understand what I'm saying. So, and the reason they teach you this is not to tease you, is not to say, oh, this is Cees Veth and it has to be good. It has a reason, because when the pipe is installed and the process is running and there is a maintenance to be done, so there has to be a pressure transmitter has to be taken out. You don't take the MPT thread of the transmission, you take that piece of tubing, right?
Right.
And you take it away, and the ferrules are still in good shape. You calibrate the equipment, you clean the existing T-piece or whatever, and you clean the nut, and you make sure you install it. Do you ever have seen the stainless steel quality of the thread from the Cees Veth nut? You should take that apart and have a good look on it, how it's made. It's not cheap stuff, it's good stuff.
Oh, okay, yeah.
Cees Veth is not cheap, but Cees Veth is the program of Cees Veth till 6,000 psi. They used to have 10 years ago, the series called Snow Trick. They don't have it anymore, but they used to have Snow Trick.
Snow Trick went to 1,000 bar.
Wow.
That's what? That's 1,500 psi, 15,000 psi. Yeah, about. And there was a kind of what do you call it? Ferrule on the outside of the tubing. Okay. What I say, three different things. Pressure, 5,000 megapascal, 500 megapascal. High pressure, 1,000 megapascal. Ultra high pressure, 1,500 megapascal. That is my law. You know, you read on Google, high pressure transducer, 100 bar. Come on, guys, this is no high pressure. One bar can kill you. That's another issue. So the other thing I do is that if you see the difference between steel, stainless steel, 316, 304, 321 is occasionally, and all the other, what do you call it, twin ferrule manufacturers of couplings, you used to have Swayzlock and Gyrolock, what do you call it in English? And the Dutch gas and oil industry used both of them. There was a kind of competing by then, you know, what is the best. But, so I went, I don't know, 30 years ago, I did a course for Swayzlock, and I had all the Swayzlock equipment, the good benders, you know.
Yeah.
And I stopped bending tubing above 10,000 psi. Then I'm not going to bend anymore.
Got it. That's a good tip.
We have a program in Europe that goes to 15,000 bar. You can bend it. It's 916 by 1/8. It's some big baby to bend, though. I mean, you need some muscles and a big vise
those
and
bending
a bench
tools.
in order.
Yeah.
Oh yeah, so you buy an elbow.
A bending,
right?
they sell them.
Right.
Yeah, they sell them. So you cut very clean the tubing. You make sure it's 90 degrees. You deburr it. You cone it. You thread it. And yeah, you have to. You know, it's not a big deal, but you have to look at what you're doing and why you're doing it. And as soon everything is in one line, okay, that is the second range, till 10,000 bar. And the couplings that I use are contra-coned shaped seals. So how do I say that? It's a cylinder with a bow top and bottom with a fine hole in there, and that lays in the female section of the coupling.
Sure.
And then goes up to 30,000 bar, no problem.
Wow. That's incredible.
And, well, I had a plumber the other day looking at it, and he really freaked out when he saw the gauge going up that high, 15,000 that was.
Oh, yeah.
And a week later, we installed an outside tap for the watering the garden. We're talking about 1.6 bar, brass, 12 mil, half inch.
Sure.
And we installed it, and he opened the main line. Guess what? It was leaking. So he had to grab two wrenches and to give it another, I don't know, an eighth of a circle, and then the thing was closed. So all I'm saying is that you have to know what kind of application you're working on, meaning-wise, material-wise. Flow is not important. The main issue by tubing is, okay, this is contradicted. How much capacity runs through the tube? Well, that is for high pressure not important. So, you know, and then there are lots of pressure tables that tells you the ID, the wall thickness for the correct pressure range, and so on and so forth. And those books are not made for Sunday morning. Those books has a very important issue to make. So take your time and read it, because it's dangerous for your customer, but it's dangerous for you, and you have to do it in that order. First for you, and then for the customer. And do as what my old man always said. Replace yourself in the situation that you are the customer, and some clown is showing up who's going to do it.
Yeah.
So do it good, or don't do it at all.
Right. Exactly.
Simple.
Yep.
Hey,
And,
hey, Case. So, Case, we're running. We like to run these for about an hour, so we're getting close to the end of that hour. So, if you don't
okay.
mind, at the very end, we
No.
always like to ask a kind of a fun question. Over your time in Cal, has there been any weird or really funny or strange calibrations that you have seen or done? We had a Howard Zion come on and talk about he had to calibrate a wobulator, which was really interesting to find out what a
A
wobulator
what
is.
waiter?
A
Wobulator.
wobulator. You'll have to listen to their podcast
Okay.
to understand what it is. I don't remember what it was.
Cees has probably launched some railroad ties
In
into
Holland,
space.
So, do
in
you have
Holland,
any
we
weird
used to say,
ones?
can you eat it? Okay. Well, I had received a question about the tear gauge
Tear
A
gauge.
tear gauge.
without spelling it.
Okay.
So tear,
Uh,
like crying tears.
that sounds like it, but it's not what I meant.
Okay.
To tear.
Oh,
tear
Oh,
gauge.
tear.
Okay,
Like you're
like tearing
tearing a
paper.
piece of paper. Yep.
Right. Does it sound familiar?
Yeah,
No,
like
I
tearing a
haven't.
piece of paper. Yeah,
I
I'm
mean, I
not.
would think
Yeah.
it's a force gauge of some kind, but
Yeah.
Yeah,
Mhm.
it was a big baby, big frame, big die-cast piece of system with a pendulum hanging in there
wow.
with a facility of a
Wow.
Stanley knife. You know what I mean, though.
Yep.
Mhm. Yep.
Yep.
You got some linoleum carpeting, and the linoleum had a thickness of about what, I don't know, 16th of an inch
Sure.
Okay.
thicker. And then you have to calculate the energy that is needed and the time it needs to fall down from an X height with an X gravity and an X mass with an X.
Oh.
A lot of X's though. And
Wow.
happened to be that there is a company in Sweden. I'm talking about 35, 40 years ago.
Sure.
A couple of days, during the Flintstones. Anyway, and I was trying to find out how that works, but it was a manufacturer down in Malmö, in southern Sweden. And he sent me a remarkable procedure with about something like 15 pages to do the right setup for the right procedure on the right time of the day with lights, and it was amazing. So I
Wow.
said to my customer, um, how much money you have in mind for doing this? How many hours? I mean,
Yeah.
So he said, right. I said, well, you better make some coffee. I'm coming over to explain you this because I have to do this. This is fun. And by the time I was talking to him and we finished 7 cups of coffee, he didn't understand shit from Shadow.
Awesome.
But anyway, sometimes people don't have an idea what calibration, is it needed? And I buy it brand new, so it's calibrated.
Yeah, right.
Yeah. Isn't that what you do? Well, you don't just throw it
It's
out.
perfect.
You don't just throw one out and then buy another one because it's a lot easier just to buy a new and never worry about whether it was good or not and just get a new one. No, that's not what not to do. But many manufacturers, we see that with you hear about it, and in pressure gauge is one discipline or equipment piece that people do that all the time, where they buy one pressure gauge. They said, well, its calibration is 2024, and guess what? They're going to buy next year around the same time. They're going to buy the exact same pressure gauge and never send it off to be calibrated because
they could have a whole drawer full.
Oh,
like,
yeah,
where they just go and check them out a new one. Yeah.
Several industries do it. All the time. If they need to just fix this, you like you said, Ryan, in case, just pull it out of the drawer, put it in. Don't really care about whether it's calibrated or not. Oh, I need a sticker. Well, yeah.
Yep. I've seen that.
Indication only, right?
Yeah.
Well, Case, once again, thank you for coming on the show. If people want to get a hold of you, what's the best way? Is it probably LinkedIn?
They can do LinkedIn or they can email it to CWS at, HPFM.
Sure.
We can put that. Ryan can put that on.
I can put that in the notes, and then also check out Metrologist magazine. From what month was that, Henry?
I misspoke. Yeah, I have it right here. It is January. It's Metrologist Volume 16, number 1, 2023. And that is free now. NCSLI, I misspoke earlier. So if you just go to NCSLI, you do not have to be a member. You can access all the issues of Metrologist magazine. Cases is the latest that's been published. And I think there's 15 pages on high pressure and some interesting. I encourage everybody to check this out. There is a very good story here. And some awesome pictures.
I'll try and put a link to the magazine.
I put it in our chat, but that's not going to help anyone listening.
Well, thank you once again, Cees and Henry, as always, being the super co-host and super podcast planner. And we shall still see everyone again here soon. I think we'll have another episode after Cees. So once again, everyone, thank you for listening and Cees for coming on the show. And talk to you all later.